So now in this try it exercise, we're still simplifying radicals, but we're looking at radicals with variables and variables that have exponents on them. The same basic process applies. If we're taking a square root, we're looking for factoring out perfect squares, cube root, perfect cubes, so on and so forth. The difference is that we're using variables, so it's just a matter of looking at the exponent, and also that because we're using variables, we have to remember when we have an even root using our absolute value rules. So with this first problem, part A, we're given the square root of b to the fifth. So we want to factor out any perfect squares. Well, a perfect square, when we're talking about exponents, would simply be any exponent that is even. So b to the fifth is b to the fourth times b. That simplifies to the square root of, we could say b squared if we wanted to write it that way, times the square root of b. Now we should say it's the absolute value of b squared, but we know b squared is positive because any number times itself, any number squared is positive, so this is going to equal simply b squared, and we're still left with the square root of b. And again, we didn't need the absolute value because the variable is being squared. So simplified, the square root of b to the fifth is b squared times the square root of b. Part B, we're looking at the fourth root of y to the sixth. So first we factor out whatever perfect quad we can find, and that would be any multiple of 4. Well, the highest multiple of 4 that is less than 6 is simply 4. So this would be the fourth root of y to the fourth times what's left. 6 minus 4 is 2y squared. We break that up into the fourth root of y to the fourth times the fourth root of y squared. Now in this case we have even root, even exponent, and it's not left with any even exponent when we simplify. This isn't, like where we had b squared squared. We're taking the fourth root, so this is the fourth root of y to the fourth, even root, even power. We need our absolute value. So that's the absolute value of y times the fourth root of y squared. And again, we needed the absolute value because what we're left with isn't being squared or taken to an even power. It's just simply y by itself, and since it's to the first power, we have to indicate, since y could be negative, that we're taking the absolute value. Last but not least, with part C, we have the cube root of z to the fifth. So we want to factor out perfect cubes. That would be the cube root of z cubed times z squared. Again, we separate it into separate radicals. The cube root of z cubed times the cube root of z squared. It's an odd root, odd power, so we don't need to worry about absolute value. This is simply the cube root of z cubed is z, and we're left with the cube root of z squared.